All right, let's consider our last example for this week. In this case, we're in the growth worksheet of our Excel workbook. Here, we're interested in studying the effect of sunlight exposure on the growth of a particular plant. We set up an experiment that exposes the plant to different amounts of sunlight and records their average net growth in inches per week. So it looks like we have a very organized amount of sunlight exposure that we're giving to different plants, and then we're keeping track of their net growth per week, right? So how much did they grow week by week, measured in inches. So we're going to do a regression analysis. Both of these are continuous quantitative data, right? We want to look for whether or not we have a relationship between them, and if we do, we're going to try to describe what that relationship is using a regression line. So we're going to get started by regressing this growth variable, which is in column B, onto the sunlight exposure. All right, so again, give yourself a chance to test today. Pause the video, see if you can run this regression analysis. All right, so we go into the data ribbon, data analysis, select regression. And now, sometimes it'll save your inputs from last time, so occasionally you have to clear them out. We want our Y range to go from B3 to B33. I kept track of what my rows were, 3 to 33 in this case. And our X range goes from A3 to A33. Our confidence level is a little different. We want to select a confidence level of 97%, so I'm going to change that. And I'm going to change my name of my output worksheet to growth regression. I'll leave my residual plots, my normal probability plots, and I'm ready to hit OK. So once again, we can take a quick look at our normal probability plot. Take a quick look at our residual plot. And we have the rest of our output here. So the normal probability plot in this case does not quite look as nice as linear, but again, remember, these things only have to loosely follow a straight line. So this will be good enough. It's not perfect, but it's going to be good enough in our case. So it's not so obviously that this is violating our normality assumption that we're going to have a cause for concern. In terms of our residual plot, this more or less looks like random scatter. We've got some above, some below, with no discernible pattern in your residuals here. So it looks like our assumptions are good. So for this question 0, can we trust the results of this regression? We're going to say yes. The residual plot looks like random scatter. And the normal probability plot does roughly follow a straight line. Okay, so we're good with that particular, just give myself a little extra space here. We're good with question 0. So let's start in at question 1. Fill in the blanks. We can be 97% confident that the slope term at the population level falls between what and what? All right, so pause the video, see if you can answer this. All right, so we're talking about a certain confidence level. We're 97% confident here. And we're referencing the slope term for our regression analysis at the population level. So what we want to do is jump back into our growth regression analysis output, and we want to grab the 97% confidence level estimates, which are sitting here, and put them in the underlined or in the empty spaces. So remember, the quickest way, rather than trying to say, all right, 0.1158, the quickest way to transfer information over is to just cell reference. So hidden equals in this sign, grab the lower 97%, hidden equals in this cell, grab the upper 97%, hit enter. And now we've finished that problem, okay? So a couple of things that we can say about this. Our slope is definitely a positive slope. So if we have a significant correlation here, the relationship should be as we increase the sun exposure, the net growth per week is also going to increase. And we can even describe sort of the effect using the slope, but I think there's a question about this a little later on. Okay. Question number 2, if this type of plant gets 2 hours less sunlight each day, what effect would we expect to see in this plant's average growth? All right, so in other words, if we decrease the amount of sunlight exposure by 2 hours per day, what effect are we going to expect to see in this average growth? Now, before you try this out, notice that we're not mentioning a confidence interval here. So you don't necessarily have to use the confidence interval or talk about a confidence interval estimate here. You're welcome to. But in this first case, you can just use your sample estimate for the slope to get your answer. So think about this. Remember, this is related to your slope term. See if you can get the right answer. All right, so we're decreasing the amount of sunlight per day. So we're talking about a change in x. And since we're decreasing, the change in x in this case is going to be a -2. All right. Generally speaking, the expected change in y is going to be our slope term estimate times the change in x. So in this case, what we need to do is figure out what our slope term is. And we can pull that in from our regression output. So I'm just going to do a cell reference, jump into my regression output, and remember my estimate from the sample for the slope term is sitting in the coefficients column in the x variable 1 row. So my slope term estimate is a 0.206. So all I'm going to do to compute my expected change in y is take my slope term and multiply by the change in x that I'm hoping to apply. And now we can interpret this. So we would expect the average growth, since this value is negative, we would expect it to decrease. I'm going to have to create a little bit more space here. We would expect it to decrease by about 0.41 inches per week. So here's our answer. All right. Now, assuming the weakest effect at 97% confidence, what change should we expect to see in the growth rate associated to an additional 1.5 hours of sunlight per day? So in this case, for this follow-up question, we're picking a new change in x, and now we're referencing a confidence level. So we are going to use that confidence interval estimate for the slope term to answer this. And they're talking about the weakest effect. So we have to think carefully about what the weakest effect would be in this particular context. Okay, so we know we're dealing with our slope regression. Slope from the regression, we're dealing with the confidence interval estimate, and we have two different estimates here. And the slope term, the weaker slope term is going to be the one that's sort of closer to 0, the one that's smaller, which in this case is our lower estimate, the 0.1158. So here's what we're going to say. The weaker slope is going to correspond to, we'll jump into our regression worksheet and grab the smaller or the lower 97% slope estimate. So the weaker slope estimate is going to be 0.1158. Our change in x in this case is going to be a positive 1.5 because we're adding an additional, we're increasing the amount of sunlight exposure, positive 1.5. And so when we go to look at the change in y, we can just take the slope estimate we're using times the positive change in x. And now we can interpret this. We would expect an increase of 0.17, in this case it'd be inches, in the average growth per week.